Okay, let's try this question 3 here. There's question 3 we're going to do. In the diagram, ABCD is a cyclic quadrilateral, 4 points on the outside. So is ABDE, but anyways, that's one they tell us about. They say that A1 is equal to X. They give us that. That AB cuts A3 and A4 into two equal pieces, so those guys are equal. Thus, AB bisects the angle GAN. Okay. And tangent TAN, that line called tan, is a tangent to the circle. So we can look for different triangles and use the tan chord theorem. Okay. Write down 7 angles that equal X. Well, you can do them in a different order and do them in different ways, but here's the order I did them, and I can't even remember, so I'll just press the first one. This X, what does it equal? Well, X equals B1. If we look at this triangle here from A to B to E, there's an angle between the tangent and the chord, and there's an angle in the alternate segment at the top of the triangle. So B1 is equal to X, the tan chord theorem. The next one I did was E2. I got E2 is equal to X because I right away saw a Z here with these parallel lines. So E2 is equal to X because of alternate angles, AB being parallel to ED. And then what did I do? I've got E2, so maybe I could get 2 angles that open up to the same segment. Oh, I did. A3 is equal to X. Look at that, because it opens up to the same segment as E2, BD. So there you go. And A4 and A3, we were told that this line bisects it, so A4 must equal X because AB bisects the angle NAG. Well, there's 4 all done pretty quick. Let's see. Let's try the next one. Which one did I do next? I said D1 is equal to X. Well, if we've got A3 is equal to X, B1 is equal to X, so D1, we can use B1 opens up to AE, and so does D1. So D1 must be X, angles in the same segment. Let's look at the next one. I got that E1 must be X because there's the angle between a tangent and the chord AB, and there's E1 at the top of the triangle, tan chord theorem. That's another one. Well, the last one, I didn't even see it. I made a construction and found another X. I found 8 X's, but you don't have to do a construction because there's a cyclic quad, and C2 is an exterior angle of a cyclic quad. We've got all the X's now. Now the next question. The next question is, why is AB a tangent to the circle passing through A, G, and E? Well, there's your triangle. There's A3X. Well, because the angle between, if this was a chord, this would be the angle between the tangent and the chord, and it would equal the angle at the top of the triangle in the alternate segment. So then that would make it possible for a circle to go through there. And so how do we say this? We say that AB is tangent to a circle going through AG and E, and the reason is the converse of the tan chord theorem. The tan chord theorem, working in reverse, proves you can put a circle around those 3 points that make a triangle. And there we are, all done.